Quantum computing is a new way of processing information that's different from classical computers. It uses the strange behavior of tiny particles like atoms and electrons to perform calculations. How it works: quantum bits, or qubits. Classical computers use bits that can be either 0 or 1. Qubits can be both 0 and 1 at the same time, allowing for many calculations to happen simultaneously. Superposition qubits can exist in multiple states, like spinning both clockwise and counterclockwise at the same time. Entanglement qubits can be connected, so what happens to one affects the other, even if they're far apart. Potential to revolutionize computing. Faster calculations. Quantum computers can solve certain problems much faster than classical computers. New materials and medicines. Quantum computers can simulate complex systems, leading to breakthroughs in materials, science, and medicine. Unbreakable encryption. Quantum computers can create unbreakable codes, ensuring secure communication. Applications. Optimization. Quantum computers can find the best solution among many options, useful for logistics, finance, and energy management. Simulation. Quantum computers can mimic complex systems, leading to advances in fields like chemistry and materials science. Machine learning. Quantum computers can speed up machine learning algorithms, improving image recognition, natural language processing, and more. Quantum computing is a powerful new technology that uses the strange behavior of tiny particles to perform calculations. It has the potential to revolutionize computing, leading to breakthroughs in fields like medicine, materials science, and machine learning.